Okay, hello. This is Ahmed and Sadeeb. Today we are the presenter to Agentless Demystifying LLM-based software engineering agents. Hello. Okay. Uh, Large language models have been increasingly used in software engineering, not just for code generation, but for performing entire software development tasks. Researchers have developed LLM-based agents that can interact with their environment using tools, running commands, analyzing feedback, and planning future actions. These agents attempt to mimic how human developers work by iteratively taking steps to solve complex tasks. To solve software engineering tasks, researchers have been developing agent-based approaches that allow. Next slide, please. Okay. To solve software engineering tasks, researchers have been developing agent-based approach that allows LLMs to work more autonomously. One of the most well-known examples is Devin. Devin is an end-to-end LLM agent framework. Devin can analyze a user's requirements, create a plan, and then iteratively execute tasks by interacting with tools like file editors, terminal, and even web search engine. Other popular examples, including GitHub Copilot and Meta School Llama, and other things we will see in the next slides. These tools showcase the power of LLM in software development, but they also introduce complexity. Okay, next slide. Okay, while LLM agents can automate software development, they are often too complex. They need multiple steps, interact with many tools, and depend on feedback loops. But LLMs are not perfect. They sometimes struggle with decision making and get stuck in loops. So we ask a simple question: do we really have to employ complex autonomous software agents? Or is there a simpler and better way to solve these problems? To answer this, we built Agentless, a simpler way to solve software issues using LLMs without complex agents. Okay? Most LLM based solutions for fixing bugs or patching code rely on agent systems that control tools and make decisions on their own. But these agents have major problems. For example, limited context. I mean, they can't process an entire code base at once. The second thing is error propagation. Small mistakes can grow into bigger failure over multiple steps. Now, let's look at the performance of different tools in software development tasks, especially open source software development. Could you please click one more? Thank you. Agentless achieves 32% task resolution, which is higher than many agent-based solutions. Not only that, but it also highly cost effective, making it a better alternative to complex agent systems. Okay, now let's compare agentless to professional business solutions. Click one more. I mean, among all these tools, both open source and commercial, Agentless ranks ninth overall, which is impressive considering many of the higher ranked solutions are closed source and expensive. More importantly, Agentless is the best performing open source systems, making it a powerful and accessible alternative to costly business solutions. So, next, okay. Now, let's look at the results. Agents 26 open and closed source on the software engineer Lite benchmark. Agentless outperforms all open source baseline and even some closed source tools in generating correct patches. Costs only 0.7 per issue, making it far more cost effective than agent based methods, and simplifies workflows, proving that we don't always need complex agents to achieve a great results. Okay, here is next slide, please. Okay, here is how agentless works in a simple, streamlined pipeline. First, we start by localization. I mean, identify suspicious locations in the source code where the bug might be exists. I mean, like finding where the problems is. And second thing is apply effects to correct the issue to some batches. This called repair or batch generation. And the final step is batch validation. Ensure the fix effectively resolves the bugs and doesn't introduce new issues. At the end, final fix applied and successfully integrated into the code base. Okay? Since LLMs have a limited context size, Agentless follows a structured level of localization process to reduce token usage while accurately identifying where modifications are needed. First is file level localization. Agentless starts by identifying the most relevant files using a combination of the file tree and issue wrapper. It filters out irrelevant folders, embeds the remaining files, and retrieves the ones most similar to the issue description. This ensures that only necessary files proceed to the next step. Number two is class function level localization. After narrowing down the file, Agentless removes unnecessary content such as comments and unrelated code. It then focuses on function and class definition, identifying the ones most relevant to the issue. For example, in this image, the LLM selects classes like UUID field and JSON field, focusing only on key methods such as toPython and prepare value instead of scanning the entire file. This called file skeleton format, which means the skeleton format is a compressed version of the file that include only the essential parts. The third level is line level localization. Once the relevant classes and functions are identified, Agentless further analyzes their full code. It pinpoints specific lines or blocks that require modification, ensuring precise issue resolution. This step helps minimizing hallucinations and ensure that the fix is both targeted and efficient. Okay? In the repair patch generation, I mean, once Agentless has localized the issue down to the exact line of code, it moves on to generating patches for fixing the problem. Okay? So, providing context to the LLM, I mean, the LLM is giving identified code lines along with surrounding context to fully understand the issue. This helps the model generate more accurate and meaningful fixes. Generating the batch in a search replace diff format as shown in the image. The original code is scanned for a specific pattern, and this called search section. And precise modification is suggest when this called replace section. In the image, the batch suggests adding import math before from Flask import mask. Okay, in generating multiple batch proposals, instead of relying a single fix, Agentless generates multiple batch proposals for each identified issue. This increases the chance of finding a correct and optimal solution. Okay, next slide, please. Okay, once a batch is generated, we need to ensure it actually fixes the issue without breaking only without breaking anything else. This is where batch validation comes in. First, we made a reproducer generation. Generates a test case that reproduces the bug, and this allows us to validate whether a potential fix actually resolves the issue or not. And the second thing is regression test identification. Agentless looks at all passing tests in the original repository and identifies the one that should remain unaffected by the batch. And this step ensures that fixing only issue does not introduce new bugs elsewhere. Okay. Third thing is batch filtering. Now, all candidate batches are tests against the identified regression tests. Batches with the fewest failure are retained, and reproduction tests are run to confirm the issue is fixed. Okay, if no patches pass the reproduction test, we ignore those results and rely on regression tests to determine the best match. Fourth step is batch ranking. Okay, next slide, please. Okay, in the fourth step is the batch ranking. I mean, Agentless normalizes batches by removes comments, extra spaces, and standardized names using abstract syntax tree transformations. I mean, it's a tree representation of code structure used to standardize batches to ensure consistency. Then, a majority voting system is used to rank batches, selecting the most frequently occurring viable batch as the final solution. Okay, next. This slide visualize the entire pipeline from issue localization to batch validation. Let's take step-by-step breakdown. We start with the project code base and reported issue. The issue describes a misinterpretation of matrix expressions using lambda. The system then scans the repository structure to understand its organization and locate relevant files. Next, Agentless identifies the top and most relevant files where the issue is likely present. It narrows down to the specific classes and functions where the issue might be exist. Now, the system pinpoints the exact line of code that require modification, and then we are in batch generation with the issue and its location identified. Multiple candidate batches are generated to fix the problem, and then to validate the fix, Agentless creates test case that reproduce the original issue, and the generated batches are tested against these reproduction tests to confirm these resolves the issue. And the end, the batches are filtered and ranked based on correctness, minimizing failures and ensuring no regressions are introduced. And the best ranked batch is selected and submitted as the final solution. Okay, and I will give the mic to Sudu.
Thank you, Ahmed. Now that Ahmed has discussed about agentless approach and how it works, let's have a look at how it compares against the agent-based approach. So first thing first, let's have a look at how it affects the complexity. So in agent-based approach, it requires infrastructure and setup for agents to interact with the systems. The configuration and management are more complex. However, in the agentless, it is simpler in terms of workflow since no agents are involved. This results in less overhead. Similarly, in the performance part, agent-based systems can vary based on the complexity of the tasks. More complex tasks will require more resources and optimization. However, in agentless, it generally achieves higher accuracy with simpler tasks, such as bug fixes is seen with an accuracy rate of 32% on SWE-bench Lite, that is a test suite for software engineering tasks. In the cost part, agent based typically involves higher costs due to dependencies on tools or agents, infrastructure setup, and maintenance. On the agentless part, it is more cost effective with a cost of $0.70 per issue, making it an economical option for simple tasks. In the error handling part, agent based approach are uh, more prone to errors propagating, especially if agents are not correctly configured or interact poorly with other components. Agentless provides more direct fixes and validation, leading to fewer complications in resolving errors. On the scalability part, agent based can handle broader and more complex tasks but requires fine tuning and configuration to scale efficiently. However, agentless is best suited for smaller tasks like bug fixes, as it is not as scalable for larger, more complex tasks. Now, if we look at the strengths and weaknesses of the agentless approach, we can see that in this, firstly, it is very simple. The agentless approach is straightforward and does not require complex setups or installation of extra tools. Similarly, it is affordable since it does not require specialized tools or a dedicated team. The agentless approach is more cost effective compared to hiring a junior developer for small fixes. Similarly, it is more reliable as it is more consistent in its execution. Now, talking about the weaknesses of agentless approach, one major weakness would be the agentless approach can face difficulties when handling more complex tasks. For example, updating an entire API across multiple files might be inefficient or error prone. Similarly, the effectiveness of agentless approach heavily relies on the clarity of bug reports. If the description of the issue is vague or incomplete, the system may mistakenly choose incorrect files or solutions, leading to potential errors. So, where actually is the agentless approach used? Okay, so where actually is the agentless approach used and who is using agentless? So, the real world use cases are, firstly, the OpenAI utilizes the agentless approach to test and improve its models, such as GPT-4. Similarly, the startups, especially during the product testing phase, use agentless approaches to fix bugs faster. This is crucial for them as they need to be agile and responsive to issues in order to meet tight deadlines and improve user experience. Similarly, the teachers also use agentless solutions to automatically grade student coding assignments. It helps in efficiently identifying bugs or errors in student submissions and providing consistent, accurate feedback without requiring manual review. One example would be a fintech startup used Agentless to fix 15 bugs in their payment system overnight, saving 20 hours of developer time. So what can be the next steps for agentless, and the future improvements for agentless approach would involve handling bigger projects. It, that is, teach the agentless approach to handle large complex code base such as Google search engine, so that currently the agentless approach is great for smaller projects but needs enhancements to scale efficiently for bigger, more intricate systems. By improving its capabilities, it can handle more sophisticated tasks. Similarly, it can be expanded, the agentless approach, to support a wide variety of programming languages such as JavaScript, Java, and C++, which are commonly used in the production environment. Currently, the agentless approach is most effective in Python. Expanding its compatibility with other languages will allow it to cater a broad range of use cases. Similarly, enabling integration with popular developer tools like GitHub and GitLab to automatically suggest code fixes would be another future improvement. So, the dream scenario would look like a future where Agentless quietly fixes bugs in the background, letting the developers focus on creative work. Finally, complexity does not necessarily mean better results. And there are scenarios where simplicity can outperform agents. Thank you.